Hello, everyone. This is Dr. Shiva Ayyadurai. We're going to do a session today, a talk today on what I'm calling the science ain't settled. And again, this is Dr. Shiva Ayyadurai. As many of you know, I'm an MIT PhD. My PhD is in the field of biological engineering, and I have a bunch of degrees from MIT in multiple fields of engineering. But what I really wanted to focus on today was to really look at three issues. And to just give you an introduction, we may do more detailed versions of these in future lectures. But I want to really go over three things that are examples of the way that science has been compromised, not only in the United States, but throughout the world. One is the area of climate change. The other is genetically modified foods or genetically engineered foods, which are known now as GMOs. And obviously vaccines. The topic of vaccines, which many of you have been following me on. But let's begin by sort of laying out the larger architecture here. What is it? Whoops. Let me go back to this. A little issue here. What is it that I believe that which means our goal is? As some of you know, when you look at it from a systems approach, the goal is to actually know what the goal is. I think most people want truth, freedom, and health. And I really want to sort of consider that in a important way. Their goal, which is the opposition's goal, is power, profit, and control. And the way that the enemy, which is what I characterize them, achieve power, profit, and control is through exclusivity, is through opacity, is through reductionism, centralization, censorship, and depersonalization. So what do I mean by that? Exclusivity is the aspect of where people try to keep everything unto a small set of people because they believe they know best, that they're better than you, they're better than me. But the theory is that it's a small set of people thinking they know what's best for all of us. The next piece that I talked about is opacity. It's really the opposite of transparency. It means that a set of people want to keep things very secret within that very exclusive group. So the concept of opacity needs to be understood because it means that people are trying to keep things secret. If you try to get data from people, it's very difficult, and we'll talk more about this. The next aspect of this is reductionism. That means a very complex thing is taken and it's reduced to one single part. So if you remember, I've talked about the concept of the six blind men looking at the elephant. If the elephant represents a complex problem and the blind men are touching pieces of it, the guy who touches a tusk thinks it's a spear, etc. But it's people taking a very large system like the elephant or climate or genetically engineered foods or the immune system and reducing it to one part. Those in power love that. It's sort of the tools of fake science. The next part is centralization. This means that they control all the means of distribution of information, which means through particular journals, through particular media houses, etc. And the other piece is censorship. Censorship meaning that other opposing views are censored. Only a certain set of views are even seen as acceptable. Other views are laughed at or really not accepted for any type of discourse or debate. And then finally, you have the aspect of depersonalization, which means everything or you or I are looked at as essentially one lump of, so you don't look at people as individuals, you look at everything as one big statistical blob, because when you do that, you don't have to worry about the differences among a particular situation. You can depersonalize the whole thing. So this is in stark opposition, I keep doing this, sorry, this is in stark opposition to what I believe our goals are for truth, freedom, and health and the principles that drive that. And I've laid them out in our seminars that we offer. And those six aspects are inclusivity, transparency, systems thinking, decentralization, freedom, and personalization. So let me go through each one of these. The inclusivity aspect means we want to include as many people as possible. So I've started promoting the concept, which others have talked about before, but really making it real, where we're actually training people in what we call citizen science by teaching people systems thinking. So the issue is you bring a lot of people into the conversation. The other is transparency, which means data, content is shared. A lot of people do not want to share data. They want to keep it very, very insular. When experiments are done that you and I fund to major scientific institutions, they're not shared with people. The next part is systems thinking, which means taking, really understanding the whole. When you look at the elephant example, we actually start understanding the whole. We don't just take parts of it. And then finally, we recognize that there's a lot of smart people in the world. It's not only a few people sitting at Harvard, MIT, Stanford, that we decentralize science itself, that we let lots of people participate, not only a few. And as a part of this, freedom is very important to this, because freedom means you support open discourse, open debate. You take as many views in. You're not afraid of opposition. And obviously, as we'll talk about, the concept of scientific consensus is used as a way to constrain freedom. And you also recognize that when you look at a problem, particularly in biology and other fields, that personalization becomes very important, that one size does not fit all. So let's just sort of jump into it right now. And what I want to talk to you about is really the aspect of what goes on when we look at how these three things interact together, which means truth, freedom, and health. How do we actually, what is the scientific process? How do we actually get to truth? So if you look here, in my book, Climate of Science, I talk about this. But if you look at getting to scientific truth, or for that matter, truth in general, how do we get there? Well, first of all, you have to apply the scientific method. And you have to apply what I call systems thinking, which others have also called. Jay Forrester was one of the leaders in this at MIT. But the concept here is, if you want to get to truth, we actually have to have freedom. And that freedom enables us to actually practice a scientific method and take a systems approach. So when you practice a scientific method, which is basically the idea of you make an observation, from that observation you make a guess at why you think that observation is going on, and that guess leads to a set of experiments. And those experiments give you results, and from those results you try to match, did your hypothesis of why you think that observation took place match what you actually saw? And it doesn't matter, as Richard Feynman said, how good looking you are, what family you come from. If your guess, your hypothesis doesn't match the results, your science is wrong. So that's that aspect of the scientific method. That leads to truths, and those truths are constantly being questioned, by the way. When Newton came out with the law of gravity, in Newton's laws, it took many years later until Einstein found out that under certain conditions, those laws break down at, for example, the speed of light. So that even truth itself, science is constantly questioning. But based on the truths you get, you can now identify the real problem, and then you can innovate real solutions for our health. So you go from freedom to truth to health, and if you're healthy, we can create, meaning you personally or your society, we can create great infrastructure, and we can start creating resilient systems, which are strong systems for your body or in general, and that gives us actually the strength to actually fight for freedom. So all these things are, in my view, very intimately connected. You need freedom so you can apply the scientific method to get to truth, and from truth we identify real problems and real solutions from which we can get to health, and from health we're strong so we can actually fight for freedom. So it's all interconnected. So that needs to be clear. Truth, freedom, and health is really an important aspect of how all these things work together. The other piece here is, let's actually now use this to actually start looking at how things actually work. So what I want to do is, first of all, start with what is evidence? What is evidence? It's a very important question. What is evidence? People say there's evidence that the Arctic ice sheets are melting. So I want to start with climate change. But we need to understand what is evidence. A colleague of mine, a recent friend, Dick Lindzen, has really laid out a very nice definition in one of his papers, which I want to use, which is it's unambiguous prediction. So let me talk about this. So when someone says, I have evidence that the Arctic is melting from the climate, from the climate model, what do they actually mean, that the Arctic is melting from the climate model? So if someone says this, what are they actually saying, right? So the issue is, what is evidence? And in order for something to be evidence, there cannot be ambiguity in their predictions. It means evidence is something that is unambiguously predicted. Unambiguous prediction. So this is something that needs to be understood. So if someone says, the climate models predict the ice is going to melt by 2100 in the Arctic, that means that their predictions are unambiguous. That means in order for that to be evidence, in order for their predictions to be evidence, it means it has to be an unambiguously predicted. Unambiguously predicted. Okay? So let's think about that. Unambiguously predicted. In the case of climate change, you have a very, very complex system. You have the sun, which is around 6,000 degrees Kelvin, sending radiation to the Earth. Some of that radiation, about 340 watts per meter, hit the Earth. 140 watts per meter bounce off the atmosphere. 200 watts per meter come in. And that it's an accounting problem that needs to be dissipated, and occurs through typically convection, where you recognize that the surface of the Earth is at a certain temperature, and because of the interaction of two turbulent fluids called the atmosphere and the oceans, through convection, that remaining 200 watts per meter is dissipated. This, by the way, what I just said, no one disagrees with. The issue is, everyone also agrees climate does change, that CO2 is a greenhouse gas, and greenhouse gases increase temperature. However, the issue in science is how much, and that how much is people have tried to predict using these models. And those models, for example, have been trying to predict how much ice sheets melt. But remember, evidence is unambiguous prediction. So if we go back to that definition, which I don't think anyone will disagree with, and you actually take something like what I'm about to share with you here, the Arctic. So there's models. There's around 40 different models when they do all this calculations. By the way, the calculations are based on data, which itself is ambiguous. But if you look at this, each of these lines that you're seeing here, each of these lines, there's lines, for example, at the bottom, the dotted line, all the way to the top, the solid purple line, and everything in between. These lines are predicting. This is according to the IPCC model forecast for the summer minimum in Arctic ice in the year 2100 relative to the period 1980 to 2000. So they're using the period 1980 to 2000. So between 1980 to 2000, based on that data, they're then predicting what's going to happen in 2100. And what do you see here? You see no unambiguous predictions. You, in fact, see 40 different predictions. This is essentially, choose whatever flavor of ice cream you want. This is not science. This is not science. It's indeterminate. Let me tell you how screwed up this is, and the fact that people are buying this is, again, if you look at this, it's not unambiguous prediction. In fact, there's multiple predictions. This would be us accepting Newton's laws by, if Newton had said, well, when an apple falls from a tree, there could be 40 different positions Newton's models would predict. One is the apple goes to the ground. Another model would predict that the apple was suspended at 2 feet from the air, 4 feet from the air, 10 feet. It's complete BS. So I wanted to share this with you. And also, if you look at the climate model predictions of what the climate is going to be in the future, it too is, there's about 140 different predictions. The bottom line is that the climate is an extremely complex system, and if you want to start predicting it, and you want to use those predictions for driving policy, which is how much money you and I are going to pay out of our taxes, supposedly to some event that may occur based on these kinds of predictions, you really have to start questioning what kind of science this is. And I'm here to tell you, this science is not science. It's not based on evidence. Let me also, what I'd like to do now is, I hope this is clear. If you have any questions, please post them right in the comment section. But the thing that I'd really like to now talk about, another topic, is the topic of GMOs. If you apply the same thing in GMOs, many years ago, around 2013, I got involved in the GMO discussion. And the GMO discussion is quite fascinating because just like you have the quote-unquote pro-vaxxers, anti-vaxxers, pro-climate, anti-climate, you have this whole thing with people who are on the pro and non-GMO side. In fact, what was interesting for me was that in this discussion, there was people like MIT, in fact, who got into this, and MIT had published this article, I think it was 2014, which said, "Buy fresh, buy GMOs." And it's quite interesting because this is in Technology Review, at the MIT Technology Review. I've been on that cover many years ago for some work I did with email analytics. So it's considered a very, very prestigious scientific magazine. But on that magazine, as you can see, there's this cover that says "Buy fresh, buy GMO." And as you read it, and by the way, it's making fun of the "Buy fresh, buy local" movement. So as you read this article, it almost seems like it's an ad for big ag, big Monsanto. And as you go through it, you find out that the entire article really is promoting the fact that we need to all move to GMOs because the poor people in Africa and India need it. Otherwise, they're going to die and there's going to be huge suffering. When, by the way, that the concept of needing GMOs to feed the world is an absolute lie. There's a couple of great information that's out there that we did many years ago. We did a debate, in fact, in India. And the deputy director of the agriculture group said, look, it's not about GMO seeds. It's total nonsense. It's about irrigation. It's about getting tools. It's about educating people on how to do farming practices. The GMO stuff is way, way down on that bottom of that list. So how did GMOs get out there, and what is the quote-unquote science used to validate them? Well, the science that's used to validate them, as you can see in this diagram, is that the FDA, by the way, which takes a hands-off, basically says that as long as a manufacturer doing their own self-reporting can say that the GMO that they're developing, for example, the GMO tomato, if someone was to make a GMO tomato, is substantially equivalent to the non-GMO, which is, let's say, the organic version. So if you and I started a GMO tomato company and we said our GMO tomato is the same as the non-GMO, then then you can use that as a basis of putting it out to the public. The FDA, by the way, takes a very, very hands-off approach to this. So if you go back to here and we look at this, and I want to walk you through these slides now, is that in 1976, Gerald Ford, the president after Reagan signed into law, after Carter signed into law this bill, which said that you could use substantial equivalence as a basis for determining equivalence in, so you can fast track products. It came out of medical devices. Medical devices used to take a long time to obviously go through the regulatory process, which is not a bad thing. But if someone made a itsy weeny tiny weeny change to that product, it would take a much equally long time. So for example, if you built a stethoscope and later maybe you just wanted to change the color of the stethoscope from black to white, you'd have to go through this long process. So it was a good law in the sense it allowed us to accelerate innovation. So when GMOs came out, people decided that they would use this apply the same law to actually understand substantial equivalence. So for example, when soybeans came out, by the way, 97% of the soybeans in the United States are genetically engineered. So when the soybeans came out, the issue was, could you actually determine its equivalence? And so what the GMO seed companies did was they said, well, it's substantially equivalent to the non-GMO version. So how did they do that? According to the substantial equivalence principle, they get to choose whatever criteria they want. So they could have chosen the color of the seed, how green the plant was, etc. They get to choose the criteria, and then they get to compare it. So when I got involved in this, I said, well, can there be objective variables that you should compare this to? And unlike the reductionist model, what we did, as I'm going to show you here, is we took a very different approach. We actually went through many, many scientific articles using a technology that I created called Cytosolve. So we went through 6,837 scientific experiments, across 184 institutions in 23 countries. And we ran it through our system. As you can see here, we took all those papers, we identified all the molecular mechanisms, and we really went and built a much more robust understanding of what happens when genetic engineering takes place. And what we discovered when you connect all the dots, which is using a systems approach, not using a reductionist approach, is that when genetic modification takes place, it affects a whole bunch of pathways in oxidative stress, which then affects a set of pathways that are involved in C1 metabolism. The box that you see in yellow, every plant in the world undergoes C1 metabolism. It's how it sequesters carbon. And that means it's a cyclical process where it undergoes a methionine biosynthesis, the methylation cycle, and formaldehyde detoxification. To put it simply, from a systems perspective, every plant does these three processes. It actually creates formaldehyde, plants, fungi, and bacteria, and then they clean it up using a very important antioxidant called glutathione. So the point is, we took all of the data, we didn't cherry pick, and we built a systems approach, as you're seeing here, to understand what is going on at the physiological mechanistic level with plants. What we found out was when genetic modification takes place, and we found that when the genetic modification of the gene that they take from the bacterium and they shove it into the soy plant, that genetic modification actually leads to the upregulation of many, many different kinds of, it perturbs the system. And in particular, what we find is that the plant actually goes into oxidative stress. What we found was that very similar, and this is using our interaction of all these biomolecular pathways, that very much when a plant undergoes drought or when a plant undergoes different types of stresses, the plant will actually go into a mode where it uses up its antioxidants, glutathione levels drop, and formaldehyde will actually accumulate. And interesting enough, that is what our models actually predicted, as I'm going to show you here, that the plant actually is in what is known as oxidative stress or allostasis that you can see here. So formaldehydes, which normally drop, they actually start accumulating here. So what you see is that you have accumulation of formaldehyde that takes place. In the normal case, in the non-GMO case, formaldehyde levels drop and they're cleaned up. But in the non-GMO case, formaldehyde levels accumulate. And interesting enough, what you notice is the glutathione levels, which is the antioxidant, also get depleted and they go to a different steady state. The point being that when you actually connect the dots, what you find is that a itsy weeny teeny weeny change with the GMO companies say they're absolutely safe, there's no issues, when in fact they don't have any real safety risk assessment. What you find is that there is a perturbation. The key thing being here is the glutathione levels drop and the formaldehyde levels will increase. Now, when we published this, a bunch of our opposition, people like, there's a guy at Folta at University of Florida, attacked us, said, oh, this guy is a fraud, he didn't invent email, which I did, by the way. So personal attacks, and then went on to say that these are just models, they're not real. Well, fortunately, we were able to find some wonderful research experiments that were done in the University of Leeds. By the way, what I'm sharing with you here, I'm about to share with you here, is these are papers that we published. We published it in the same journals that the USDA and Monsanto published in. And what you'll see here is that when we published these, we were attacked initially saying this is just a model, but then we were fortunate to validate our mechanistic analysis with actually data that appeared. So what you see here is, and look very carefully here, you'll see over here in the first row is our, on the second row is our prediction called in silico from Cytosolve, predicting how much glutathione levels are in the organic, 9.749, and we predicted in the transgenic with Roundup Ready that it would drop down to 3.9. That's what you see there. So 9.79 dropping down to 3.9. Now what you see here is in the actual wet lab experiments, they find that the organic has 9.9 and 3.7, so pretty close. The point is that we understood mechanistically by connecting all the dots that the genetically engineered version of soy is different than the non-genetically engineered, the organic version. And if they had used glutathione levels, which are a much more objective analysis, that this should never have been allowed out into the public market, because it's almost a 250% difference. So I hope that's valuable for you to understand. Again, the science that GMOs are safe is not settled. Just like climate change, the extremes that the world is going to end, and all those kinds of things which are being predicted by climate change, the science is not settled. Let me move on now to, as I promised, to vaccines, because you start noticing a very similar thing occurs with vaccines. And in particular, that we are today doing science on, at best, a 50-year-old, at worst, a 150-year-old model of the immune system. And that's what I want to walk you through. So some of you may know that the immune system is composed of two subsystems, the innate immune system and the adaptive. And to think about it this way, you can think about the innate immune system as that system which is composed, as you see on the left side, of your skin, your cough, your tears, your mucosal layer, your stomach acids. This part of the immune system is what faces the outer world. It's like your shield, your physical shield. So when a virus hits, it may come through your skin, it may come through your tears, your eyes, through your mucosal layer in your stomach, etc. And that innate immune system has various cells. We'll do a much more detailed understanding later, but monocytes, macrophages, neutrophils, NK cells, dendritic cells, these are the things that first see the attack of the virus or the pathogen. And then after that, then your adaptive system kicks in, which has B cells, T cells, and the adaptive system creates a particular antibody. So basically what happens, to think about, is your innate immune system. This is, by the way, the classic old model theory, is the first line of defense. And then if that fails, and then your adaptive immune system creates specific antibodies. So you have the innate and the adaptive. And that system of the immune system is what is typically taught to people in the medical world. So based on that model of the immune system, people have built medicines and sort of the foundation. So again, the innate immune system, a little more detail. It's primitive, it's immediate, it's on or off. That's what the plus or minus means. Its potency is lower, it's fast. There's no significant amplification. The duration is short. The old theory, that it has no memory. Recent data that just came out about a couple years ago says that's not true. And then the adaptive, as you see, is highly specific. It occurs a little bit after. There's a 3-day lag. So your innate immune system kicks in 3 days later, your adaptive kicks in. It has much more levels of regulation. It's not just on or off. Potency is known to be higher. The amplification means it amplifies what it does, means the level of antibodies that are put out can be amplified. The duration is long, and it has a memory, etc. The point is, these two systems are characterized as two different models. And diagrammatically, you can think about it. A pathogen hits the innate immune system. This is a 2-compartment model. And then there's a process which kicks in the adaptive immune system, which creates antibodies. And the notion of vaccines is we're going to short circuit the innate immune system. We're going to go right into the adaptive immune system. We're going to put a vaccine right into the bloodstream. And as a result of that vaccine going into that bloodstream, voila, you get antibodies. You should be happy. So again, it's a reductionist. There's two problems here. First of all, as you'll see shortly, this model is based on a model of the immune system that's 50 to 100 years old, seriously needing an upgrade. And I shared this at one of the recent National Science Foundation lectures. So the bottom line is, this model is old and it's reductionist. It's reductionist because they're saying that the entire immune system's efficacy is going to be reduced to one variable, which is antibodies. Similar to the climate change. We're going to take the entire climate change and reduce it to one variable, CO2. The reality is, when you really look at this, when you really go back and we really look at this very carefully, what we find is that the immune system, at minimum, has another subsystem that is the interface between the innate and the adaptive, and it's called the interferon system. The interferon system generates interferons, alpha, beta, gamma interferons. So when the innate immune system gets on, another subsystem, the interferon system, gets engaged, and that interferon system then is a transition to the adaptive immune system. But the interferon system itself upregulates interferons, which protect your body from many, many viruses. It's called interferons because Sachs and Lindemann found out in the 50s to the two scientists that when you expose a rabbit, for example, to, or the skin of the rabbit to a certain virus, that rabbit was protected from other viruses. So listen very carefully. The interferon system protects you from many other viruses. So you could easily argue that resilient, healthy systems are supposed to be exposed to pathogens, and then you get protected to other viruses. This is an important aspect that's left out of the entire quote-unquote bad science, fake scientific discussion, or limited scientific discussion on the vaccine discourse. So this is, again, very important to understand. That process needs to be understood. The second process is, so if you look at, if you have the innate, the IFN, and the adaptive, on the left side, right? On the right side, you're comparing giving a vaccine at the adaptive level, which is what we do today, versus exposure, where you're actually exposed to measles. So let's say you got the measles MMR vaccine, which is injected into your adaptive system, versus you actually being exposed to it, which would hit your innate, your IFN would get turned on, then your adaptive. So the question is, what is the risk of getting the vaccine? What are the benefits? Similarly, what are the risks and what are the benefits? And I've discussed this in a previous video, but this is the real question. And this question is not being able to be understood because we don't have the data. But history shows that when some of these vaccines were created, people decided randomly at what risk level should a vaccine be created. So for example, with the measles vaccine, it was decided because a certain set of the population, around 0.001% of the population, was getting neuroinflammation. This is around 1963. Therefore, that was a high enough risk for us to create the measles vaccine. However, after vaccinations, we're noticing in the general public, around 1 to 36, 1 out of 88 kids, it's in that range, are getting neuroinflammation. So the issue is, was the risk analysis done? And if the risk analysis was not done, you must give choice to people because the science was not fully, taken to the full analysis of understanding risk. So let me finish up by, when you look at this diagram and we look a little bit clearer, we actually understand that the modern theory of the immune system, which I presented at the National Science Foundation about a month ago, less than a month ago, is that it's not just the innate and the adaptive. The modern, the reality is that it includes multiple systems: the microbiome, the stuff in our gut, the innate, the adaptive, the interferon, the neural. And so therefore, I can with confidence tell you that the science ain't settled on vaccines, just like the science ain't settled on GMO safety, just like the science ain't settled on climate change. Why? Because people are trying to take very, very complex systems and reduce them into simple parts. So for example, with climate, they're trying to take a very complex system and reduce it to a single variable CO2. And they're using mathematical models where the data that they're getting, the so-called evidence, is not unambiguous predictions. In the case of GMOs, they're doing a small little change and telling us everything is fine because they are choosing what variable to measure. It's fake science. When you actually do a systems analysis, you find the right variables to measure, and those variables show that there is a substantial difference between, for example, soy, GMO soy, and organic soy. And then when you look at vaccines, you find out at minimum we're using a 50 to 100-year-old science. As you can see, this is the complexity of the immune system, and we're putting in we're putting in vaccine into the adaptive and saying measuring antibodies. This is why I have a serious problem with this, and this is why I say the science ain't settled on this. The other piece that I want to share with you is that when you really go back to this diagram, which I really want to make sure you leave with, is that the goal here is truth, freedom, and health, which is, by the way, the core of the campaign I'm running for U.S. Senate. It's really a citizen science, a systems revolutionary campaign. We want to train all of you guys to be citizen scientists because you cannot really trust most of the academic establishments today because the approach that there is no critical thinking fostered. Academics are essentially chasing grant money all day long. And so the model has been completely subverted. But if we go back to the fundamentals of truth, freedom, and health, we have to fight. We have to fight for freedom. We have to fight for open discourse. We have to fight against all those people who try to censor anything. That's why the recent the recent article I wrote talking about this health choice group, which essentially is trying to censor the movement, censor what people can talk about. That same type of censoring is what goes on in science. We're never going to win. We have to have full-blown freedom. We have to have discourse and debate. And that creates the environment where we can actually do the scientific method in systems thinking. So it starts with freedom. From that, we have the opportunity to discover truth, which is a very difficult process. And from that aspect of discovering truth, we can now start figuring out what is a real problem, what is a real solution. So if you look at climate change, the real problem is pollution. It's not CO2. CO2 is not a pollutant. If you look at GMOs, the real problem is that we have the essence is we don't do proper irrigation, we don't do proper farming techniques. We're actually destroying the soil with these pesticides. Because the soil's being destroyed, people are then coming up with other back-end solutions which profit Monsanto, for example, on both sides. They make money from selling their herbicides, money from making their GMO seeds, and then they put neonicotinoids on it. It's a whole nother discussion, but the point is, it's fake science, fake problem, fake solution. But if we do the real problem and the real solution, then we get health for not only our bodies, but our health in our society. And from that, we can actually be strong, because in order to fight for freedom, you need to be strong. So there's a very important argument to be made here. If we're being made to be weaker people, weaker infrastructure, do we even have the strength to fight for freedom? So anyway, this is Dr. Shiva Ayyadurai. I hope this was valuable. But my interest in doing this is to really educate all of you. This is not personal. None of this is personal for me. This is the fact that there are forces who want power, profit, and control, and they do it through exclusivity. They do it through opacity. They do it through centralization of power. They attack freedom. They try to censor depersonalization. And the only way to win truth, freedom, and health is through bringing people together, is through educating people, being transparent, teaching people a systems approach, supporting open discourse and debate. And that is what I'm dedicated to. You're all invited to come to our event we're doing tomorrow, Thursday. But the bottom line is we're going to be doing systems thinking, systems revolutionary citizen science seminars broadly every Mondays at 7 p.m. Regularly to help educate all of you, so all of you can be leaders and system scientists and citizen scientists. Anyway, thank you. This is Dr. Shiva Ayyadurai. I hope this is valuable. I may take a few questions. Are there any questions people have? If there's any questions, we have about 75, 80 people on. Any questions? Libra Girl says, thank you. You're welcome. Any questions on this? So we hopefully have let you know that the science is not settled, be it the science of the immune system, the science of quote-unquote climate change, or GMOs. GMOs have no safety assessment standards. There's no risk assessment standards for vaccines. It's based on an old science. And then the climate change, fake science is pretty bad. There's no evidence. It's unambiguous predictions. Anyway, thank you very much. Be well.